All right, so our last day of review, the way this will work is here's our first problem that we're going to do. We're going to work backwards from problem 7. You guys are going to work this one out, and then you're going to pause my video, work this out, and when everyone's got it worked out, you'll unpause it and see how you did. All right, so go ahead and start working this question out. Someone press pause, and then when everyone's done, go ahead and hit unpause and watch. All right, so the way this one works out is we look closely and we notice that the x plus 4's cancel. So that means we do have a hole when x is equal to a -4, right? We'll figure out the y value in a bit. Domain be all reals except 5 and -3/2, right? Because that's when the denominator is 0. Also, we can't equal -4, right? Because we've got a hole there. Vertical asymptotes are the same. And I guess I should go ahead and put those in. And -1.5, right? Horizontal asymptote, if we were to multiply out this entire numerator, the top would be 4x to the 3rd. And if we were to multiply out the denominator, it would be 2x to the 3rd. Well, they're the same power, so y is equal to 2. Oops, just notice my mistake here. -1.5 would be our other vertical asymptote. We have a horizontal at y equals 2. There's no slant asymptote. Let's see, x-intercepts, that's the zeros. That's when the numerator is equal to 0, which would be at 1/4 as well as +3. So there's 1/4. There's +3. We don't need to worry about the y-intercepts. To figure out this hole, we've got to take our reduced problem, right, and put a -4 in for the x. So we're going to have see -4 -16, so -17 times -7 divided by -5 times -9. We multiply this out. Let me get my calculator. We get about 2.6. So there's going to be a hole at -4 at 2.6. There's a hole right there. Now let's see if this is enough to graph. We'll be coming like this. Here, we're going to be doing one of these. Now, on the right side of that, I think I'm going to need to put a point in and see what happens. see, 1, 2, 3, 4, 5. Let's put a 6 in. And let's go ahead and calculate what the y value is. So it'd be, and again, what I'm using is that setup, right? Plugging in a 6 in for the x. 6, 12, 15. All right, so use my calculator here. I end up with about 4.6, which is here. That's enough information to draw that. Okay, not too bad. Let's, if you want to look at this, feel free to pause it, but I'm going to move on to the next question. Okay, here's our next one. Go ahead and pause, and then when you're done, unpause it so you can see how I did the question. All right, so what I would do is, the first thing I would do is I would take care of this vertical asymptote, right? The next thing I would take care of are the zeros. And I can see I had a typo here. I meant to say that this is the horizontal is y equals 0. And if I look at my problem here, I can see that in the denominator, I've got an x cubed. The numerator is just an x squared. Since the bottom is bigger, y equals 0. Cool. Okay, if we want to look at this, hit pause. Otherwise, we're going to move on to the next problem. Okay, here's the next one for you to do. And again, press pause so you can work it out. When you're done working out, everyone press unpause and watch how I did it. All right, so we got to find a couple things here: the vertical asymptotes, the horizontal asymptotes, the slant, the holes, and the zeros. Well, first, I think we should factor this problem. This problem factors to be the following. Does it factor? No, it doesn't factor. So that's cool. That means the vertical asymptote is just going to be x equals -5, right? Because that's when the denominator would be 0. There's no horizontal, but there is a slant because the numerator's got a greater degree. So what you could do is you could just do synthetic division. Okay, we don't care about the remainder. We just look at what we're left with, which is 1x minus 7, and that's our slant asymptote. Nothing canceled out, so there's no holes. To find the zeros, that is when the numerator is 0, and since I couldn't factor it, I should try to do the quadratic formula. Now, when I work this out, I'm going to get a negative root, which, while that would be fine if we were doing some other things, but we're graphing here. You can't graph imaginary numbers on our graph. So there would be no zeros. we need to look at this more, press pause. Otherwise, we're going to go on to the next problem. All right, so here's our next one. Go ahead and press pause. And when you're done, press the unpause so we can see it. All right, so here's how to work this one out. If 3i is a 0, well, then so is negative 3i. So the factored form would be something like this. And then the next thing we need to do is we need to multiply these, right, to get the polynomial. So I'm going to multiply this first. Now that's going to give me x squared minus 3xi plus 3xi minus 9i squared, which is really, see, these cancel, x squared plus 9, right? Because we got to remember I squared is equal to -1. Now we are still multiplying by x minus 8, so I just got to distribute this. So take care of that. Take care of that. And if I rewrite it in descending order, hold on a second. This should have been 9x. Okay. Okay, if you need to look at this more, press pause. Otherwise, we're going on to the next problem. Okay, press pause. Otherwise, I'm going to go ahead and work it out. So our zeros are 8, -7, and 2. Should plot those out. 8, -7, and then 2. Now, the multiplicity for this is 3, right? Multiplicity for this is 4. That happens 1. If I were to multiply all this out, we're going to have an x cubed, an x to the 4th, x to the 1st, which will wind up to be x to the 8th. So that means the shape's going to be something kind of like that. Well, the -7, 0 is here, and we are not going to be able to cross the x-axis there, right? Because it's an even multiplicity. It's going to kind of bounce off. When we come to the +2, though, we'll be able to go through that because it's an odd multiplicity, right, of 1. And then when we get to the 8, there we go, because it's a multiplicity of 3, an odd multiplicity of crosses 3. All right, let's move on to the last two. Okay, here's one of them. Find all the zeros when 1 0 is 6i. Okay, pause it. Otherwise, I'm going to get started. So if 6i is a 0, I should be able to do this synthetically. Add those up would be 2 plus 6i. If I multiply this, we would get 36 plus 12i. Add those up would be 12i. Multiply again would be -72, gives us a 0. Perfect. 6i is a 0. I'll make my list out here. So we have 6i. We also know that if 6i is a 0, so is -6i. So we'll put -6i in there and see what we get. Yeah. Perfect, it's a 0. What polynomial is left? Well, we did synthetic twice. So this degree drops by 2. So x cubed goes down to x to the first. So this must be 1x plus 2. Well, if that's a factor, then the other zero's got to be -2, right? Okay, let's move on to the next one. Oh, that's it. All right, so keep on reviewing. Our test is on block day. I'm here in the mornings. I get here about 7:10. I'm not available Thursday morning, but I will be here Wednesday morning for anyone who wants to come by the classroom and get some extra help. We'll just work problems on the board. Take care.